Hello students, welcome back to our channel. So students, in this video we are going to study your class 11th physics chapter 3, which is motion in a straight line. Entire chapter will be covered in this video and we are going to study many important terms which are required to understand the concepts of the coming chapters. Like the terms which we are going to discuss in this video are very important to understand the concepts of chapters like laws of motion, work energy power, rotational mechanics, gravitation. So let's start. Name of the chapter is motion in a straight line. But before proceeding further, I would really like you all to subscribe to this channel because we are going to upload many important videos for your class 11th and 12th physics preparation. Okay, let's start. So students, name of the chapter is motion in a straight line. This chapter is a part of a branch of physics which is called kinematics. In kinematics, we study the motion of objects without considering the factors due to which the motion is produced. Like we will study the motion of the objects, a car is moving, a bike is moving, an aeroplane is flying, but we will not discuss the factors due to which the motion is produced. And the factor is force. Force is responsible for producing the motion in a body. But when we include force in this discussion, when we are discussing the motion of objects with force, then that topic comes under mechanics, right? And that starts from laws of motion, which is your chapter 5. In chapter 3 or 4, third one is motion in a straight line and the fourth one is motion in a plane. These two chapters are part of kinematics, in which we study the motion of objects, but we will not discuss the factor, that is force, due to which the motion is produced. Okay, so let's start. First we will discuss the types of motion. There is one-dimensional motion, two-dimensional motion, three-dimensional motion. Suppose a body is moving in a straight line. This is a road. This is a road. A car is moving in a straight line. A bicycle is moving in a straight line. Okay, so this is a road like this and a body is moving on this road. This is a body. Suppose this is a person which is moving in a straight line on this road. Exactly straight line. He is not turning towards right or left or not taking a slightest of the turns. He is moving just in a straight line, right? Okay. So suppose this man is starting from here. There is a very important concept of origin. Origin is a fixed point which we use in such situations to give the position of the object, right? If I'll say that the distance of this man is 5 meters, I have to describe the motion of this body. So I have to choose a fixed point which I'll take as origin, and that point should be fixed, because if your origin is moving like here is a car is also moving on this road, and you take this point which is on the car as origin. Now the distance of this person from car is 5 meters and this person is moving in forward direction and this car is also moving in forward direction with some different speed. So the distance between this car and this person is changing randomly. So you cannot specify the motion of this man with the help of this moving point. So we take a fixed point as origin, and with the help of that fixed point we describe the motion of each and every object moving. For example, suppose this is a fixed point on the road and this point is taken as origin. We can take any point as origin, but it has to be a fixed point. It should not move with time, right? So right now at this point of time, the man is starting from here and the distance of the man is 5 meters from the origin, and this man is starting in this direction, right? After 10 seconds, say this man is at this position and this distance is now 20 meters. So to specify the position of this man, only one coordinate is required, which is the distance of this man from this fixed origin. If we take this as x-axis, so in terms of coordinates, we will say that the position of this man is 20, 0 at this point, and position of this man at this point is 5, 0, right? So we know that if this is x-axis and this man is moving in a straight line, we need only one coordinate, because y will always be 0. Y will always be 0 because it is moving only along the x-axis. So we require only the x coordinate to specify the position of this man. Such type of motion is called one-dimensional motion. Okay. This is one-dimensional motion. This is not the two-dimensional motion. One-dimensional motion. So one-dimensional motion is when only one coordinate, there are some typos, so I am correcting those. When only one coordinate is required to specify the position of the body. For example, this is one of the examples of motion in a straight line. This man is moving on a road in a straight line. But much better example is the motion of a body falling freely. When the body is dropped from some height and it falls freely under the action of gravity, it always falls in a straight line. So if you take any point as origin, like take this point as origin from where you have dropped the body, this is the origin. And this is a fixed point. I know that I have dropped this body from this point. So you can specify the position of this body at any instant of time using just this distance, like, right, just the one coordinate. So that is one-dimensional motion. Two-dimensional motion, when two coordinates are required to specify the position of the body. For example, in circular motion, if the body is moving in a circle, or this man takes a right turn or left turn, right? Right now he is moving in a straight line, but if he takes a right turn, if he takes a left turn, then it becomes a two-dimensional motion. Another example of two-dimensional motion is circular motion. This body, suppose a body is moving in a circle in this way, and we take origin as this point, which is the center of the circle. We can take origin as any fixed point, right? Understood? Okay. If we take origin as the center of this circle, and this is our x-axis and this is our y-axis, and at any instant of time t, suppose this body is here at this point P, right? Okay. So at time t1, suppose this body is at P, and after some time, like at t2, this body is at Q. So to specify the position of P, you need two coordinates, x comma y, and also at Q you need two coordinates, suppose x dash y dash. So you always need two coordinates to specify the position of this body. So circular motion is a two-dimensional motion. Similarly, parabolic motion is also a two-dimensional motion. When you throw a body like this, when you throw a ball or something to someone, then the path followed by that ball is this. And if this is y-axis and this is x-axis, so at any instant of time, we need two coordinates. Suppose the body is at this point, so we need two coordinates to specify the position. This is y and this is x. So that is also a two-dimensional motion. And three-dimensional motion, when three coordinates are required, to specify the position of the body. For example, the motion of a kite in sky, that is a three-dimensional motion, because kite is flying in such a way that it is covering a distance in vertical manner also, in horizontal manner also, and it is only also coming towards you, right? If the kite is at this point, right? So from that corner of this room, you have to give three coordinates to specify the position of the kite. First, this distance. Second, distance from that wall. Third, distance from the ground, right? So you need three coordinates. In this chapter, we are going to study only one-dimensional motion, because name of the chapter is motion in a straight line. Two-dimensional motion will be discussed in the next chapter, which is motion in a plane. So we will discuss two-dimensional motion in that chapter. So let's focus on one-dimensional motion. Clear? Okay. So let's discuss some very important terms before moving ahead. First one is distance. If a body is moving from A to B, in real life, when a body moves from A to B, when you are leaving your place to go to a friend's house, you do not go directly, right? You follow a particular path, some road or something. So in real world, it is not possible to connect any two points, any two places or any 2 points on the ground with a straight line or with a straight road. So there must be a path like this when you go from A to B, or there can be another path also, there can be another path also. So there are many possibilities. What is distance then? So a very important line that I am going to say now, that the distance is the length of the path traveled by the body. Distance is always the length of the path traveled by the body. For example, in first situation, the body moves from A to B using this path. So the length of this path, this plus this plus this plus this plus this plus this plus this, the length of this path is distance. And in second case, length of this path is distance. In third case, length of this path is distance. So it is always the length of the path covered by the body. If the body is not moving, we cannot find the distance. The odometer which is present in your cars, that odometer is there to find the distance, to note the distance, right? Even if the car is moving backwards, it will increase, it will not decrease even when the car is in reverse mode, right? Because the distance is always the distance covered by the body in any direction. It is always the distance covered by the body in any direction. If the body is not moving, you cannot find that distance, right? In common terms, we always say that the distance between this place and that place is suppose 10 kilometer or 20 kilometer, which is wrong, because distance is always calculated according to the motion of the body, right? Another thing is displacement. Displacement is always a fixed distance between initial and final position, and that is a straight line drawn from initial to final position. Like initial position is A, final is B, and this length, a straight line drawn from initial to final position, this length is called the displacement. So body need not move along this displacement. It is always same. If the body is moving along this path, then the distance of the body is the length of this path, but the displacement between A and B always remains the length of this yellow line, irrespective of the motion of the body. And we know that the shortest distance between 2 points, from our knowledge of mathematics, we know that the shortest distance between 2 points is always a straight line drawn from one point to another point. So displacement is also defined as the shortest distance. Okay, there is another typo. Okay, don't go into the definitions. I don't know who has typed this, but this is just a random copy paste. Just listen to the points that I am covering, right? So displacement is what? Displacement is the shortest distance between the 2 points, and it is always a length of the straight line which is drawn from initial to final position. So we will define it like this only. It is the shortest distance between 2 points, right? Okay, so both are the terms of length. So standard unit of both distance and displacement is meter. Okay, so there are few differences. One difference is this: it is the total length covered by the body from going from A to B. In going from A to B, and displacement is the shortest distance between the 2 points, right? Most important difference is that distance is a scalar quantity and displacement is a vector quantity, because distance doesn't have any direction. If the body is moving in any direction, then distance will be calculated, but the displacement has a specific direction. The direction of displacement is always from initial to final position. If you show this displacement by a vector sign, then the direction of this vector is this: from tail of the vector will be on the initial point and head of the vector will be on the final point. And if the body is moving then the distance of the body is always increasing. Even if it is moving in reverse gear, the distance will always increase, right? So if the body is moving, distance of the body cannot be zero, but displacement can be zero, because if the initial and final points coincide, then the displacement of the body will be zero. Body has started from A, now in a circular manner it comes back to A again. Then the distance is this, but the displacement is what? Displacement is zero. Okay, let's discuss some examples. Question number 1. Okay, let us say that the body is moving in a semicircle. This is not a semicircle, sir. Okay, no problem. We'll cut it out. Now this is a semicircle, right? So body has started from A and the final position is B, and it is moving along this path, and suppose the radius of this circle is R. So what is the distance in this case? Distance of the body is what? Length of this, because the body is moving along this path, so length of the path, that is the distance. So length of this path is half the circumference of the circle, which is the half of 2 pi r, that is pi r, because the circumference of the circle is 2 pi r, so it is pi r, right? And displacement is what? It is the straight line distance between the initial and final position. So what is the straight line distance between the initial and the final position? This length, and it is equal to the diameter of the circle. So displacement is what? Displacement is 2r, right? So if the body is completing one circle, that we have already discussed, that if the body is completing one circle, then in one circle the total distance is 2 pi r and displacement is 0, because the body is again on the initial point and the distance between initial and final point is 0. So displacement is 0. Now let's take one more example. This is another circle, and now suppose the body has covered a distance of, let's say, 75%. The body has covered a distance of 75%. Like this. Body has started from this point A and now the body is at this point B. Okay, so now what is the distance and the displacement? So distance of the body is 3/4 of the circumference of the circle, right? Distance is 3/4 of 2 pi r. Distance is 3/4 of 2 pi r, which is 3 by 2 pi r. 3/4 of 2 pi r, which is 3 by 2 pi r. And what is the displacement? This is 75% of the circle. Now if we join these two, this is the displacement now. Let it look like a 75% of the circle, right? Okay, we have to find the length of this side, this line. So how can we calculate the length of this line? Join these two. Suppose this is the center of the circle. So what is the length of this radius? This is the radius, right? So length of this is r, length of this is r. Then what is the length of AB? length of AB is under root r square plus r square by using Pythagoras theorem. So what is AB? What is AB? AB is under root 2r, right? So that is displacement. So you can find such questions in your exam. I hope the concept is clear. Now let's move ahead. Okay, so this was distance and displacement. Okay, what is average speed? If the body is moving, suppose from point A to, let's say, a point B, the body has traveled from point A to point B. So in real life scenario, it is quite possible that the body is not able to maintain a fixed speed while moving from A to B. The speed of the body is changing due to traffic jams, due to signals, due to speed breakers, and if the road is empty, traffic is not there on the road, then the speed of the car will be more light. So in real life situations, when the body moves from one place to another place, speed of the body can be changing continuously. But if we are interested in average speed, so that means we will just, what is the formula of speed? You all have studied the formula of speed in your class 8, 9, 10, and that is distance upon time. But what is average speed? In average speed, the symbol of average speed that we are going to take is V average. V is basically velocity. You know that the speed is distance upon time, and if you remember your class 9th lectures, then you must be knowing that velocity is displacement upon time. But if the body is moving in a straight line, we have taken some examples of distance and displacement, right? That in this case, body is moving in this path, so the distance is pi r and displacement is 2r. But what is the name of the chapter? Name of the chapter is motion in a straight line. So in this chapter we are not going to study such situations. This was just to give you an example and feel of the difference between the distance and displacement, but we are not going to take such situations because this is not motion in a straight line. So as long as the body is moving in a straight line, the distance and displacement will always be same. So if velocity is displacement upon time and distance and displacement are same, so if the body is moving in a straight line, it is going in one direction only, then the distance and displacement will always be same, and in that case speed and velocity will be same. Okay, so we can take the symbol of average speed as V average, because there is no other symbol given in books for average speed, so we are taking this symbol as V average. But V is basically used for velocity, but we are using it for speed, and the logic has been explained to you. So this body is moving from A to B, so the total distance covered is, suppose from A to B, this total distance is say x, and the body has taken a time t. So average speed is x by t, which is the total distance covered. First we will write it as a formula. Total distance traveled divided by total time taken. Total distance traveled divided by total time taken. So the total distance is x and the total time is t. So average speed is x by t. Getting my point? We are not interested in what is happening in between A and B. What is happening at this point? What is the speed of this body at this point? What is the speed of body at this point or at this point? No. We are just interested in the average value of the speed. Suppose the speed of the body is 40 km per hour at this point, 80 at this point, and there was some traffic at this point, so speed of the body is reduced to 10 km per hour, suppose. But when we divide this whole distance by the total time which is taken by the body in traveling from A to B, we get suppose 60 km per hour, let's say. So 60 km per hour was not the actual speed with which the body was moving from A to B, right? It is just the average speed. For example, if this total distance is suppose 120 km and the body has taken 2 hours to cover this distance, so average speed of the body is 60 km per hour. Average speed of the body is 60 km per hour. On an average, it is moving with 60 km in 1 hour. That is the meaning of average speed, right? Okay. So SI unit of average speed is meter per second, because distance, SI unit of distance is meter and SI unit of time is second. So in numericals, we are going to find 2-3 situations and we are going to discuss those situations. In first situation, the whole path of the motion of the body will be divided into 2-3 parts. Let's divide this into 3 parts. This is point C and this is point D. And it is given that the distance AC is S1 and the distance CD is S2 and the distance DB is S3. And the time taken by body to move from A to C is T1, from C to D is T2, from D to B is T3. So in this case, the average speed V average is total distance traveled. Total distance is S1 plus S2 plus S3 by 3, right? And sorry, why I am dividing it by 3? Total distance is S1 plus S2 plus S3 and the total time is T1 plus T2 plus T3. So this will be the average speed, right? In some examples, in some numericals, it is given that the motion of this body, path of this body is divided into 3 parts. This AB is divided into these 3 parts such that the time taken by body is T1 from A to C, and again same thing, from A to C it is T1, from C to D it is T2, and from D to B it is T3. But instead of these lengths, instead of these distances, it is given that the body has travelled this distance AC with speed V1, from C to D with speed V2, from D to B with speed V3, right? Okay, so what is V average? Again, it is total distance travelled by total time taken. Some students do this mistake that they divide V1 plus V2 plus V3 and they divide this sum by 3. This is not maths wala average. We are not finding the mean. We have to apply this formula, total distance travelled by total time taken. If you are saying that this numerical is very simple because 3 different speeds are given and I have to find the average speed, then I'll add those 3 speeds and divide it by 3, divide the sum by 3. You are not going to get the answer. You have to apply this formula. Just ask yourself that in this situation, have I applied this formula before finding the answer? If the answer is no, then you are not going to get the actual answer, the correct answer. Correct answer will come only using this formula. So the total distance is what? So total distance is not given. So we have to use the formula of speed, which is speed equal to distance upon time. So speed equal to distance upon time. Then what is the formula of distance? It is speed into time. Formula of distance is speed into time. So what is this distance AC? It is V1 T1. What is this distance CD? It is V2 T2. And what is this distance dB? It is V3 T3, right? Divided by total time. This is the total distance and total time is what? Total time is T1 plus T2 plus T3. Total time is T1 plus T2 plus T3. Okay. There can be another situation also in which it is given that this whole part is divided into, now in this situation distance and time for every part was given. In this situation, velocity of time for every part was given. So what is left? Now, distance and speed. If sometimes I am saying velocity instead of speed, that is also correct because we are talking about the straight line motion, right? So in this case, it is given that this distance AC is S1, this distance CD is S2, this distance DB is S3, and the velocity of the body while going from A to C is a fixed velocity of value V1. From C to D it is V2. From D to B it is V3. Then what is the average velocity or average speed? That is total distance traveled by total time taken. Total distance is in this case is S1 plus S2 plus S3, and the total time is distance upon speed. S1 by V1, speed is distance upon time. Then what is time? Time is distance upon speed, na? So from A to C, the time is distance upon speed, that is S1 by V1 plus S2 by V2 plus S3 by V3. So total time is S1 by V1 plus S2 by V2 plus S3 by V3. So you can get these three situations in numerical problems. So we are going to discuss some important numericals based on this concept of average speed. But first we will discuss average velocity, because in those numericals this term is also included. Average velocity is same as average speed only when the body is moving in a straight line along a same direction. But if the direction of the body is changing, then average velocity is what? It is basically the total displacement over time. Now let us take an example. The body has started from this point and it has moved a distance of some distance, suppose 6 meter, and then it turns towards left and now it covers a distance of 8 meter. Now this distance of 6 meter is being covered in suppose 2 seconds, and this distance of 8 meter is being covered in suppose say 3 seconds, right? So this point is A and this point is B. So average speed, now we are talking about 2D motion because the body has taken a turn. So we cannot use the symbol V average for speed also. So we will write average speed as, we have to find both average speed and average velocity in this situation. So average speed is total distance traveled by total time taken. So what is the total distance from A to B? It is 6 plus 8. Total distance is 6 plus 8 by total time taken is 2 plus 3. So average speed is 14 divided by 5 meter per second, which is going to come 2.8 meter per second. That is average speed. So what is average velocity? Average velocity is displacement over time. So what is the displacement AB? So this is a right angle triangle. It is given that the body has taken a turn at 90-degree angle. So this is a right angle triangle. So V average is the displacement AB. V average is the displacement AB by total time, which is, time तो 5 सेकंड ही है ना, time is 5 seconds. So AB is what? We will find AB using Pythagoras theorem. So this AB is what? It is 6 square plus 8 square. 6 square is 36. 6 square is 36. 8 square is 64. 36 plus 64 is 100 and root of 100 is 10. So 10 by 5, which is 2 meter per second. So average velocity is 2 meter per second. So average velocity is displacement over time and average speed is total distance traveled by total time taken. Unit of both of these is meter per second, but speed is a scalar quantity because it is distance upon time and distance is a scalar quantity. So speed has no direction. But velocity is a vector quantity because it is displacement over time and displacement is a vector quantity. And the direction of velocity depends on the direction of displacement. Okay. Now let's take this question. It is a very important numerical on the concept of average speed and average velocity. A body travels from A to B with a speed of 40 meter per second and returns to A with a speed of 30 meter per second. Find the average speed and average velocity for the whole journey. A body from A to B, a body from A to B, a body while going from A to B had a fixed velocity of 40 meter per second, and while coming back from B to A, it had a fixed velocity of 30 meter per second. So we have to find the average speed and average velocity, right? So what students do in this question, they just add 40 and 30 and divide it by 2 because they see that there are two values and they have to find the average of that. But that is wrong. We have to apply that formula to find the average speed. Total distance traveled by total time taken. So what is the total distance and what is the total time? Both of them are missing from this formula. So students, this question, so students find this question difficult, but this question is very easy because if you take this distance AB as x, then you know that the distance while going from A to B and coming back from B to A is same because the body will cover same distance, first AB then BA, both are x. So the total distance traveled, average speed we are going to find first, average speed. So the total distance traveled is what? X plus x. Got it? This distance is x. So the total distance traveled is x plus x divided by total time taken. Time is what? Time is distance over speed. So distance from A to B is x and speed is 40. So it is x divided by 40. This is the time taken by body to move from A to B, and x divided by 30 is the time taken by the body to move from B to A, right? You just have to solve this thing because x will get cancelled out and you will get the answer. What is the LCM of 40 and 30? LCM of 40 and 30 is 120. Yeah. So 3x plus 4x, that is 7x. So this x will get cancelled out, 120 will be multiplied by 2, 240 by 7. So the average speed is 240 by 7 meter per second. You can solve it further to find the answer in decimal. And what is the average velocity? What is the average velocity? Average velocity is the displacement over time. What is the displacement? Body is again at A. Body has started from A, it goes to B, then it is again at A. So what? Initial point is A and the final point is also A. So what is the distance between the initial and final point? The distance between initial and final point is 0. So the displacement is 0 and 0 by time. Velocity is 0. Okay. Next question. On a 60 km per hour track, 60 km track, this is not the speed. On a 60 km track, a train travels the first 30 km with a uniform speed of 30 km per hour. How fast must the train travel the next 30 km so as to average 40 km per hour for the entire trip. Okay, this is a 60 km track. A to B, the length of this whole track is 60 km. The length of this whole track is 60 km. And this is the midpoint of the track. So this distance is 30 and this is also 30. A train travels first 30 km with 30 km per hour. ये पहला 30 km is traveled by the train कितनी स्पीड से 30 km per hour. And the next half is traveled. How fast must the train travel the next half? So we have to find the speed of this part. Let's say it is x km per hour and the average speed of the whole journey is 40 km per hour. So average speed is what? Total distance traveled by total time taken. Average speed is given. Average speed is 40 km per hour. So 40 equal to total distance traveled, which is 60, by total time taken. Total time is what? Total time is distance over speed. So in first case distance is 30 and speed is 30 km per hour. So it is 30 by 30. And in second case time is distance over speed. So this distance is also 30, but we do not know the speed. So let's take it as x. So this is 40. This 0 is cancelled from this 0 and 2, 3. So 2 equal to 3 divided by 1 plus 30 by x. So 2 equal to 3 divided by x ऊपर चला गया x plus 30. Cross multiply 2x plus 60 equal to 3x, which gives 60 equal to 3x minus 2x. So x is what? X is 60. So train should travel with 60 km per hour for the second half. So the average speed for the entire trip will be 40 km per hour. Correct? Next. On a 60 kilo, okay, repeated slide, this is done. Okay, now we will discuss the concept of instantaneous speed and instantaneous velocity. Students, what was the average velocity when the body is going from A to B? We are not interested in the values of the speed in between, right? We are just interested for the whole thing, right? If the body has traveled a distance of 120 km, like we have discussed, if the body has traveled a distance of 120 km in 2 hours, then the average speed of the body is 120 by 2, that is 60 km per hour. But that is not the actual speed. The speed of the body was 40 km per hour at some point of the time. At 10, the body was also moving with 10 km per hour at some other point of time, and it was at rest. The speed of the body was 0 when it was standing at the signal. So there are different values of the speed and velocity of the body when the body moves from one part to another part. But if we are interested the speed as a whole, then we take average speed. But if we are interested the speed of the body at a particular instant of time, like what was the speed of the body at 9:30 a.m. and 10 seconds, right? So at that particular instant, that speed of the body is called instantaneous speed. And instantaneous speed and instantaneous velocities are calculated using differentiation. We are not going to study the concept of differentiation here. We have different videos for that. We are just going to apply the concept of differentiation because this is the one short lecture of motion in a straight line. So we are restricting ourselves to the topics of this chapter only, right? So the displacement of particle moving along x-axis is given by this. What is the instantaneous velocity? So the instantaneous velocity is the derivative of displacement with respect to time. So it is dx by dt. So we will differentiate this. So what is the derivative of 18t? Derivative of 18. So this is also the function of time. V as a function of t. 18 plus 5t square, that is 10t. So Vt, this is Vt. This is a function of velocity with function of velocity in time. So we have to find the instantaneous velocity at t equal to 2 seconds. Now we have the function of velocity in time. So we can put t equal to 2 in this function to get the instantaneous velocity at t equal to 2 seconds. Have you got the point that instantaneous velocity is the velocity of a body at a particular instant of time? When we put t equal to 2 in this equation, we are going to get this value, which is the exact velocity of this body at exactly t equal to 2 seconds. It will going to change in just fraction of second because the velocity depends on t. So if I put t as 2.001, I am going to get a different value. But when I am putting 2, let's see what is this, what is the value. So it is 10 into 2, it is 38 meter per second. It is 38 meter per second. This is the velocity of this body at exactly t equal to 2 seconds, and that is called the instantaneous velocity, right? Okay. In second part, we have to find the average velocity between 2 seconds and 3 seconds. So what is the average velocity? V average is the total distance traveled by total time taken. This is the distance equation of the body. So if we put t as 2 in this equation, suppose this is the origin. This is the origin from where we are taking the distances. And this is t equal to 2 seconds and this is t equal to 3 seconds. So when we put t equal to 2 in this equation, we are going to get this distance, that is or displacement of the body at t equal to 2 from origin, and when we put t equal to 3 in this equation, we are going to get this whole. But we have to find the average velocity between t equal to 2 and 3 seconds. So we need this distance which the body has traveled in moving from this point to this point in this 1 second, right? So what we will do to find this distance, we will put 3 here and then minus from this distance we have to subtract this distance. So this will come after putting t equal to 2 in this equation, and this whole will come after putting t equal to 3 in this equation, which is the function x. So x3 minus x2 divided by 3 minus 2, which is 1 second. So this is the total displacement by total time from 2 to 3. So now let's first find x3. Let's first find x3. So what is x3? x3 is when we put t equal to 3 in this equation, which is 18 into 3 plus 5 into 3 square, which is 18 into 3, 54 plus 5 into 9. This is 99 meter. Okay, clear? Now we will put t as 2 in this equation. Now let's put t as 2. So 18 into 2 plus 5 into square of 2. 18 into 2 is 36 plus 20. So V average is this. x3 minus x2. So x3 is 99 minus x2 is 56 divided by 1, which is 43. So it is 43 meter per second. And the third part is instantaneous acceleration. Acceleration we have not studied till now in this lecture, but you must be knowing that acceleration is rate of change of velocity. So to find the acceleration, you have to find the derivative of velocity function. Where is the velocity function? This is the velocity function, and now when we will differentiate this function with respect to t, 18 becomes 0 and 10t becomes 10. So it is 10 meter per second square. 10 meter per second square. Right? Okay. Next question. Now here a function is given t equal to root x plus 3, and we know that to find velocity we need x as a function of t, but here it is given as t as a function of x. So we will first make it in this form that we get x in terms of t. So root x is t minus 3. This 3 is shifted on left hand side. Now eliminate this root by taking square of both sides. Now this is x, which is a function of t. Now to find what we are supposed to find the displacement of the particle when velocity is 0. We have to find the displacement at that instant when the velocity is 0. First we will find that time, right? What is the velocity? Velocity is the derivative of x with respect to t. Velocity function is the derivative of displacement function with time. So derivative of t square is 2t, derivative of 9 is 0, and derivative of 60 is 6. Now this is the velocity function. So when will the velocity be 0? Velocity will be 0 when we'll put this equal to 0. T comes out to be 3 seconds. So velocity is 0 at t equal to 3 seconds. Velocity is 0 at t equal to 3 seconds. So what is the displacement at that time? Where is the displacement function? This is the displacement function. Now put t equal to 3 in this function and we are going to get x as 0, right? T minus 3. So if we put t as 3, so 3 minus 3 whole raised to power 0. So the answer is nothing but 0. So find the displacement of the particle when its velocity is 0. So the displacement of the particle is 0 when the velocity is 0. The acceleration of the particle is given by this. If the particle starts with velocity this at t equal to 0, then find the velocity at the end of 2 seconds. Okay. We'll come back to this question after discussing the concept of acceleration. Acceleration is the rate of change of velocity. Acceleration is the rate of change of velocity. So what is the meaning of this statement? If the motion of the body is not uniform, what is the uniform motion? A body is said to be in uniform motion when it covers equal distances in equal intervals of time. What is uniform motion? When the body is covering equal distances in equal intervals of time. Like the body is traveling with a speed of 1 meter per second, say, and that is not the average speed, that is the fixed speed of the body. which means that the body is covering 1 meter in every 1 second, right? In 1 second the distance is 1 meter, then in next 1 second also the distance covered by the body is 1 meter, then in next 1 second also the distance covered by the body is 1 meter. This type of motion is called uniform motion, and in such case we say that the body is moving with uniform speed. And if the body is covering different distances in equal intervals, like in first second the body has covered a distance of 1 meter, but in next 1 second the body has covered a distance of suppose 1.5 meter, and in next 1 second the body has covered a distance of suppose just 20 centimeter, then this type of motion is called non-uniform motion, and in this case the body is said to be moving with non-uniform speed, right? So when the speed is non-uniform, we can have two cases. In first case, just give me a sec. When the distance is when the motion is non-uniform and the body is moving with non-uniform speed, there are two possible cases. First, the speed of the body is changing in a random manner, like in first 1 second it has covered a distance of 1 meter, in next 1 second the distance is increased to 1.5 meter, but in third second the distance is decreased to 20 centimeter. So the speed of the body is changing in entirely random manner. This is a case that we are not going to study. In non-uniform motion, we are going to study a very important case of uniformly accelerated motion. It is a motion in which the speed of the body is changing, but it is changing in a uniform manner. For example, suppose now this is a timeline. Let's divide this timeline into equal intervals of 1 second, let's say. We have divided this timeline into equal intervals of 1 second. 0, 1 second, 2 second, 3 second, 3 seconds, 4 second, 5 second, 6 second, and so on. Now let's say the speed of the body was 0 at this point and it was 2 meter per second. I am not writing meter per second because it will take some time and jagah also. So I am just writing the numbers. You just assume that this speed is in meter per second. So 0, 2 and 4 and 6 and 8 and 10 and 12. So the speed of the body is increasing in a uniform manner. The speed of the body is increasing by a value of 2 meter per second in every second. 2 meter per second in first second, then again the speed of the body is increased by 2 meter per second in second, and by 2 meter per second in third second, again by 2 meter per second in fourth second, and so on, right? Okay, so we can say that the speed of the body is increasing by 2 meter per second in 1 second, and this value is called acceleration. We are talking about the rate of change of speed and velocity. We are strictly discussing about a straight line motion. So acceleration is mainly, it is rate of change of velocity, but I am just saying speed to make you understand the concept, right? It is velocity. So acceleration is the rate of change of velocity. How much velocity is changing per second, that value is called the acceleration of the body. And zaruri nahi hai ki velocity is increasing, it can be decreasing also. So acceleration will be negative. How we are going to find the acceleration? Suppose we have to find the acceleration in this case, which is that we know it is 2 meter per second square. We call it 2 meter per second square, but basically it is 2 meter per second, right? It is 2 meter per second. We are saying that the velocity of the body is changing by this value, 2 meter per second in 1 second. So it is 2 meter per second, but this second will be multiplied with this second, and the answer mathematically it comes out to be 2 meter per second square. So we call it, the SI unit of acceleration is meter per second square, but that means meter per second, right? Okay, so how we will find the acceleration in this case? We will say that acceleration is v2 minus v1 divided by t2 minus t1. v2 minus v1 divided by t2 minus t1. v2 is the velocity at some later time t2 and v1 is the velocity at some former time t1. For example, just pick two times. 2 points we are going to pick from this timeline. Suppose one point is this and the other point is this. So what is the change in velocity? What is the change in velocity from this to this? Change in velocity is 10 at this point minus, this is v2, minus v1, 4 at this point, divided by the time taken, which is 5 minus 2. So acceleration is 6 divided by 3, 2 meter per second square, right? So it is change in velocity by time taken to change the velocity. Change in velocity by divided by time taken to change the velocity. And if the rate of change is not uniform, for example, now let's take one more example. Look at this timeline. Suppose the velocity of the body is 0 here, 2 here in meter per second, 4, not 4, let's say 5, let's say 10, let's say 13, let's say 18, right? So we can clearly see that the velocity of this body is not increasing with a uniform rate. Now if we take these two times, suppose this, and we find the acceleration, which is 18, let's take these two times, right, which is 18 minus 2. 18 minus 2 is change in velocity, divided by 5 minus 1 is change in time. So it is 16 by 4 and it is 4 meter per second square. This acceleration is 4 meter per second square. And this acceleration will be called average acceleration, because acceleration is different for every second. Velocity has changed by 2 meter per second in first second and 3 meter per second by 3 meter per second in second second. So acceleration for this part is 2 meter per second square. Acceleration for this part is 3 meter per second square. Acceleration for this part is 5 meter per second square. For this part also it is 3 meter per second square, and for this part it is 5 meter per second square. So acceleration is different for every second. So if we are finding the acceleration for 4 seconds, so it comes out to be the average value. So this is called the average acceleration. And this is the acceleration because acceleration is same at every point. So average acceleration, and the other one is instantaneous acceleration, that will give you the acceleration at a particular instant of time. If the acceleration is continuously changing, like in this case, we can find instantaneous acceleration at a particular instant of time, and that is equal to the derivative of velocity with time. That is the derivative of velocity with time. Clear? Okay, now let's come back to that question. The acceleration of a particle in meter per second square is given by this. This is the acceleration A 3t square plus 2t plus 2. This is the acceleration where t is in second. If the particle starts with velocity v equal to 2 meter per second at t equal to 0, then find the velocity at the end of 2 seconds. Okay. We know that the acceleration is what? Acceleration is dv divided by dt. Now the dt will go to that side. Now we will get this as dv, and we know that at t equal to 0 velocity is 2 meter per second, and we have to find the velocity at the end of 2 seconds. So we will integrate it from 0 to 2 because we know the limits of time 0 to 2, and we know the limits of velocity. At t equal to 0 velocity was 2 meter per second. At t equal to 2 we do not know the value of velocity, so let's take it as v. So what is the integral of dv? Integral of dv is v. Here it is lower limit and here it is upper limit. Now find the integral of this thing. What is the integral of this? 3t square, 3 into t square का integral is t cube divided by 3 plus integral of 2t is 2t by 2 plus integral of 3 is 3t, and put the limits as 0 to 2. Now take upper limit as v and subtract. What we do here, we put first upper limit in place of this variable, so we first put v instead of v minus, then we put the lower limit which is 2, and again 3 से 3 cancel, 2 से 2 cancel, we are left with t cube plus t plus 3t, and first we will put 2 in place of 3 t, sorry, minus we will put 0 in place of t, but all these have t, so 0 0 0 all will become 0. Okay, so v minus 2 equal to 8 plus 2 10, 10 plus 6 16. So what is v? V is 16 plus 2, that is 18 meter per second. Clear? Okay. Next. This is already discussed. This is already discussed. Okay. Equations of uniformly accelerated motion. There are 3 very important equations that you have studied in class 9th also. They are called the equations of uniformly accelerated motion. So we are going to derive those equations first, and then we will discuss some numericals based on those equations. So what are the equations? Suppose at this point we know that the velocity of the body is u, and after covering a displacement s, this hole is displacement s. This hole is displacement s. Now at this point, after covering this displacement s, the velocity of the body is v, and the time taken by body to go from this point A to this point B, that time is t, and rate at which the velocity has changed, matlab acceleration, that is a. So we will derive 3 different relations between these variables u, v, t, a and s, and those equations are called the equations of motion. First equation is derived using the meaning of acceleration, the formula of acceleration. Acceleration is what? Acceleration is the rate of change of velocity, right? So from A to B, acceleration is what? Change in velocity is v minus u divided by time taken from A to B is t. There are three different methods in this chapter to derive these equations. This first method is called the algebraic method. Then we will derive these equations using calculus method, and then we will derive these equations using graphical method. So first let's focus on this algebraic method. So cross multiply AT is V minus U. So V equal to U plus AT, and we all know that this is the first equation of motion. Okay. Second equation starts with the formula of V average that we have to discuss first. V average is U plus V divided by 2. In stats, if the numbers are increasing in a fixed order uniformly, if the numbers are increasing uniformly, we know that the velocity is increasing at a fixed rate A. So the value of velocity is increasing in a uniform rate from U to V, right? So in that case, average velocity can also be calculated using this formula. Minimum value of the velocity during this time, minimum value of the velocity plus maximum value of the velocity divided by 2. But this formula cannot be used if the velocity is changing in random manner. In this case, the velocity is increasing in uniform manner, so we can use this formula to find the value of average velocity, which is u plus v by 2. What is the meaning of average velocity? Suppose let us say that u is 10 and v is 30. So the average velocity comes out to be 10 plus 30 by 2, which is 20 meter per second. So what is the significance of this value? 20. So average velocity gives you a value such that if the body travels with a fixed speed from A to B and it covers the same distance in the same time, which is done in this situation, then what should be that fixed speed? Got it? For example, suppose the velocity of the body at this point it was 10 meter per second, and at this point it was 30 meter per second, right? And in this case the average velocity comes out to be 20 meter per second. So this is one situation when the body is moving with an accelerated motion, that the speed of the body is changing continuously, and suppose this distance is s and it is covered in time t. Now we want to take another situation in which the body has covered the same distance in same time with a fixed speed. Then what should be the value of that fixed speed? If the body covers this distance x in time t, then the speed of the body will be 20 meter per second throughout. Then it can cover the same distance in same time which it is covering in this situation, right? So that is the value of, that is the meaning of the word average velocity, which is u plus v divided by 2. So it is simply, it is a fixed value of the velocity, and since velocity is displacement over time, so we can say that v plus u by t, that is average velocity, is s into t, right? Okay, if you put v equal to u plus at in this equation, if you put v equal to u plus at in this equation, plus there was another u here, divided by 2, let's do one thing, because on LHS of this equation we are going to get s, so it will be better if we write this s into t on LHS only, right? So let's write s into t here. S into t equal to v plus u divided by 2. Okay, so not s into t, it is s by t. Velocity is distance displacement over time, so it is s by t. Okay, now multiply this t, so you will get u plus u, which is 2u, so 2ut plus at square divided by this 2. So s is, now divide this and this by 2, so we will get ut plus half a t square, right? So this is the second equation. Okay, third equation will also be started from this. Again use this step, and s is what? S is v plus u by 2 into t. S is v plus u by 2 into t, and using first equation find the value of t. What is the value of t? Using this equation find the value of t, which is v minus u divided by a. So the value of t is v minus u divided by a, which is a plus b into a minus b, is the identity of a square minus b square. So it is v square minus u square divided by 2a. So v square minus u square equal to 2as is your third equation. So these are the three equations of motion. Apart from these three equations, we have another equation which is called the fourth equation of motion, which is for the distance traveled by the body in nth second. Okay, I'll explain. Distance traveled by body in nth second. What this equation is about? Distance traveled by body in nth second. This equation will give us the distance traveled by the body in a particular second. For example, let us say that this is a timeline, and this is the time 0, and this is time t equal to 10, and this is the time t equal to 9. If we want to find this distance which is traveled by the body from 9 to 10 seconds, yani ki distance traveled by a body in a particular second, to find this distance we can use a long method, that using equation 2. This equation gives the distance of the body traveled in first t seconds, right? This will, if I put t equal to 10 in this equation, I am going to get this whole distance, and if I put t equal to 9 in that equation, I am going to get this distance. But what about this distance? This distance will be the difference of these two distances. So this d capital D10, which is the distance traveled by body in 10th second, is S10 minus S9, right? Okay, So this is the concept. So if we take this 10 as any second n, if we take this as any second n, so this one is n minus 1. So what will be dn? That is the distance traveled by nth second. That dn will be what? That dn will be what? That dn is Sn minus Sn minus 1. Sn minus Sn minus 1. Okay, so we are going to get questions based on this concept in which we have to find the distance covered by the body in a particular second. So we do not want to apply this long procedure. That's why we are finding a small equation for this using the second equation. What is Sn? Sn is un plus half an square. What is Sn minus 1? It is u n minus 1 plus half a n minus 1 square. Now we will solve it. Okay, so this equation is u minus a by 2 plus an. So if we multiply this part with 2 and divide with 2 and we take u plus a by 2 as common, then a by 2 यहाँ क्या बचा 2n, a by 2 बाहर चला गया, यहाँ क्या बचा 2n minus 1. So we will remember this concept as this equation. Now if it is given that we have to find the distance traveled by the body in suppose 10th second, we will put n as 10 and u or and a must be given in the question itself. Okay. Now we will derive these three equations using the calculus method. Now the situation is same. The body is, the velocity of the body here is u and here it is v. Take a very small portion of the motion of this body in which the distance of the body is ds, time taken by body is dt and velocity change is dv. Okay, and this distance is 0 and this distance, total distance is s. Time here is 0 and this time is suppose t. So the limits of time are 0 to t and limits of distance are 0 to s and the limits of velocity are u to v. Okay, for first equation we will apply the meaning of acceleration, which is dv by dt. So what is the value of dv? Value of dv is a into dt. So the total velocity change is u to v in 0 to t. So the integral of dv is v and limits are from u to v equal to a. Integral of dt is t and limits are from 0 to t. Okay. Now upper limit minus lower limit equal to a into upper limit minus lower limit, and we have arrived at this equation v equal to u plus at. Second equation. For second equation, we are going to use this concept that v is ds by dt, or we can write ds equal to v into dt, or we can write ds equal to v is what? V is u plus at into dt. Now integrate both sides. Limits of s are 0 to s and limits of t are 0 to t. Now let's integrate. What is the integral of ds? Integral of ds is s, limit is 0 to s. Integral of u is ut and integral of a is a तो constant है. Integral of t is t square by 2 and limits are 0 to t. Now let's put upper limit minus lower limit, and upper limit is t. If we put t in place of t, then this is going to come as same at square by 2 minus, and let's put 0. So this is 0, this is 0, and this whole is 0. So s is what? S is ut plus half a t square. This is the second equation. These are the derivation. This calculus method is very important. Okay, now let's discuss the third equation. For third equation also we will start from this step, a equal to dv by dt, and we will multiply, because third equation does not contain time, so we have to eliminate this term of dt. So how is this possible? We will divide it by ds and multiply it by ds by shifting this dt slightly, right? What is ds by dt? Ds by dt is v. Displacement over time is velocity. So dv over ds into v. So this gives a ds equal to v dv. Now let's put the limits of displacement 0 to s by integrating both sides, and limits of velocity as u to v. A is constant. Integral of ds is s, limit 0 to s. Integral of v is v square by 2 u to v. Put upper limit minus lower limit. Finally, bring this 2 on this side. So 2as equal to v square minus u square, which is nothing but the third equation. Right? So these two derivations of 6 equations, 3 with this algebraic method and 3 with calculus method. Any derivation can be asked in exam if these derivations are discussed in your school. A motor car starts from rest and accelerates uniformly for 20 seconds to velocity of 20 meters per second. It then runs at a constant speed and is finally brought to rest in 40 meters with a constant acceleration. Total distance covered is 640 meters. Find the value of acceleration, retardation and total time taken. So what is the question? A motor car starts from rest. Suppose this car is starting from rest from this point, so u is 0. It accelerates uniformly for 20 seconds. For 20 seconds, it is accelerating. That means its velocity is increasing. And velocity is, after 20 seconds, the velocity is 20 meter per second. It then runs at a constant speed. Now it runs for some time as with this constant speed of 20 meter per second, and it is finally brought to rest in 40 meter with a constant acceleration. It is finally brought to rest in 40 meter. This distance is 40 meter, and now at this point this body is at rest. So the total distance covered is 640 meter. This plus this plus this. This total distance is 640. Find the value of acceleration, retardation and total time taken. So let this point be A, this point be B, this point C and this point D. So we can divide this motion into 3 different parts, and for each part some parameters are known and some are to be calculated. So let's first take part AB. Part AB. So for part AB we have u as 0. For part AB u is 0 and v is 20 meter per second. U is 0, v is 20 meter per second and time is 20 second, right? Time is 20 second. So what is acceleration? Acceleration is v minus u divided by t, that is 20 minus 0 divided by 20. So acceleration for this part is 1 meter per second square. So this is the answer of first part. Acceleration is what? Acceleration is 1 meter per second square. Okay. Retardation. Retardation means in this part the body is accelerating and in this part the acceleration is 0 because body is moving with constant velocity for part B to C. So if it is asking for retardation, then this is for part CD. So let's take part CD. Now for part CD, what is the data? At this point, the velocity is 20 meter per second, which can be taken as u for part CD. So u is 20 meter per second and v is 0 because the body is finally at rest, and the displacement is 40 meter. So now we have to find the retardation, so we can use the third equation, v square minus u square equal to 2as. So a is what? It is minus 400 divided by 80, which is minus 5 meter per second square, and that is retardation, right? And now the third one, total time taken. Total time taken is time of this part plus time of this part plus time of this part. For first part we already know that the time is 20 seconds. Now let's find time for part BC. For BC part, acceleration is 0, so we can directly apply the formula speed equal to distance upon time. So speed is 20 distance upon time. Okay. First we have to find this distance because we do not know this distance yet. So let's find the distance AB. For AB we can apply the second equation. So S is UT, U is 0, तो वो पूरा 0 हो गया. Then half AT square. A is what? A is 1. So half A T square. So this distance is 400 divided by 2, that is 200 meter. This distance is 200 meter and this distance is 40 meter. Then this BC distance is what? The total distance is 640 meter. If we add 200 plus 40, that is 240, and then we subtract 240 from 640, then this distance BC is 400. So time for part BC, let's take this time as T1, and for part this it is T2, and for this part this time is T3. So T2 is what? This time is distance upon speed. So 400 divided by speed for this part is 20. So it is 20 seconds. So T2 is also 20 seconds. है ना? T1 was 20 seconds, T2 is also 20 seconds, and we can now find T3. Because for this part we already know all the data. So let's apply. Where should I write it? Okay, I'll write it here. For T3, we can apply the first equation, V equal to U plus AT. So V equal to U plus A is minus 5 into T. So this T3 is 20 by 5, that is 4 seconds. So total time is T1 plus T2 plus T3, which is 20 plus 20 plus 4, that is 44 seconds. Correct? Next. A body covers 12 meter in second. Second means only this distance 12 meter is covered only in the second. So for this question we are going to use that equation, the fourth equation of motion, dn wali. This is given as d2. D2 means distance covered in second, and 20 meter in fourth second. So D4 is 20 meter. How much distance will it cover in 4 seconds after the 5th second? So we have to find its distance in 4 seconds after the 5th second. What are the 4 seconds after the 5th second, 6th second, 7th second, 8th second and 9th second? So we have to find this distance S, which is S9 minus S5. Clear? This will give us the distance traveled by the body in 6th second, 7th second, 8th second and 9th second. That makes 4 seconds after the 5th second. So how we are going to find it? We will apply two equations. What is the formula for dn that we had discussed? Dn is u plus a by 2 into 2n minus 1. So we will apply this formula for this. U we don't know, plus a we don't know, into 2n minus 1, because this is second. So the equation is 12 equal to u plus a by 2 into 4 minus 1. 12 equal to u plus a by 2 into 3. This is our first equation. And now let's make second equation for D4. 20 equal to u plus a by 2 into 2n minus 1. So 20 equal to u plus a by 2 into 7. Now this is our second equation and this is first equation. We can use these two equations to find the values of a and u by using elimination method or substitution method. Okay, we will use elimination method. If we subtract these two equations, 2 minus 1 gives 20 minus 12. 20 minus 12, u minus u कट गया 0. 7a by 2 equal to 7a by 2 minus 3a by 2. So it is 8 equal to 7 minus 3 is 4. 4a by 2 is 2a. So acceleration is 4 meter per second square. Acceleration is 4 meter per second square. and if we put acceleration here, let's put the value of acceleration here. So 12 equal to 4 plus 3a by 2. 12 minus 4 is 8. 8 into 2. Oh, a is 2, not u. So 12 equal to u plus 3a by 2. This is 2, 2 into 3, 6. So u is 12 minus 6, that is 6 meter per second square. So these are the values of u and a. So now we will find what we are supposed to find, Sn minus S5. So S is S9 minus S5. So S9 is U T plus half A T square minus S5. So U T half A T square, because we are going to subtract this whole from this. So when we open the bracket, this plus sign will also become minus. So answer is 54 plus 81 into 2, 162 minus 30 minus 25 into 2, 50. So this is 6216, right? Minus 611 yes, minus 80. So 216 minus 80 is 126, correct? 136 meter. So body is going to cover 136 meter in 4 seconds after the 5th second. Motion under gravity. So students, when a body falls freely, its acceleration is fixed, and that is called acceleration due to gravity, and you all know the value of acceleration due to gravity, which is 9.8 meter per second square. So when the body is falling freely, acceleration is 9.8 meter per second square, which can be taken as 10 to make the calculations easy. But it's all about the sign of g, which confuse students. So we always take, how we are going to take x and y axis, that is entirely up to us, but we always take x and y axis in this manner, like this is always positive x axis, we take this as positive y, we take this as negative y, and we take this as negative x, because this makes things easy, because this is the manner in which we have studied this coordinate system for our whole lives. Yeah, so we are going to take the signs in this manner only. And since acceleration due to gravity always acts in downward direction, so we are always going to take g as minus 9.8 meter per second square according to these sign conventions, minus 9.8 meter per second square, because in the questions that we are going to have like this in this chapter, body is traveling in two different directions. First is moving in upward direction, then it is going in downward direction, or first it is going in downward direction, then it is going in upward direction, depending upon the situation. So if in the same question the body is changing directions, then we have to use sign conventions. If we do not use sign conventions, then we have to solve that question in two different parts. First the body is moving upward, then in second part. This was done in class 9, but we are not going to do this in class 11th. We are going to solve this any question in easiest manner possible, and that is possible only when we take sign convention. So we are going to take g as minus 9.8 meter per second square always in all questions, right? If the question is easy, the body is going only in one direction, then we can avoid sign conventions and we can take G as positive when the body is going downwards and negative when the body is going upwards, like you used to do in class 9. But if the question is such that the body is changing directions in the question, then we will use these sign conventions. For example, let's take this question. It is given that a ball is thrown vertically upwards with a speed of 19 meter per second. Okay, let's shift it. We now do not need this thing, so थोड़ा जगह बनाया जाए ऐसे, right? A ball is thrown vertically upwards with a speed of 19.6 meter per second from the top of a tower and returns to earth in 6 seconds. Find the height of the tower. It is given that a body is thrown, suppose this is a tower and the body is thrown in upward direction from top of this tower and it finally returns to earth. It finally returns to earth in 6 seconds. The total time from suppose this point A to this point C, the total time is what? It is 6 seconds. And we have to find the height of the tower. So let the height of the tower be h, and let's take the origin as this point from where the body is thrown. This is our origin. So all the distances will be measured from this. So what is given? T is given as 6 seconds. G we already know, minus 9.8 meter per second square. U is 0. U is not 0, sorry. Why would U be 0? U is 19.6 meter per second. U is 19.6 meter per second positive, because the direction of U was this, and time is scalar. We are not going to talk about the sign of time because time is scalar and it is always going to be positive, but the value of U should be positive because U is in upward direction, and according to our sign convention this is positive y-axis. So U is positive 19.6 meter per second. Okay, so we have to find the height of the tower. Okay, so the three equations, first equation V equal to U plus AT becomes V equal to U plus GT. We have to put just G in place of A, and when the body is moving in vertical sense, then we do not call it as distance, though it is distance, but we call it height. So we will replace S by H and A by G. So the second equation becomes, which is S equal to UT plus half AT square. This equation becomes H equal to UT plus half GT square, and the third equation, which was V square minus U square equal to 2AS, this equation becomes V square minus U square equal to 2GH for vertical motion. Okay, now let's put these values. So H is, we will use the second equation because the parameters that are known here can be put in second equation, right? So all the things are given. Let's put UT plus half GT square. So this is the answer, 19.6 into 6 minus 9.8 into 36 by 2 is 18, and 18, okay, 18. So what is common? 9.8 is common because 19.6 is also a multiple of 9.8. So it is 2 into 6, which is 12, minus 18. So 12 12 minus 18 is minus 6. So minus 9.8 into 6, and that is minus 58.8 meter. Why is it negative? Why h is coming out to be negative? Because in our perspective, the way we have taken positive x and y axis, this should be negative because this is the origin and this h is measured in the negative y direction. That's why it is negative. So the height of the tower is 58.8 meter. Correct? Okay. One more. Two balls are thrown simultaneously, A vertically upward with a speed of 20 meter per second from the ground and B vertically downwards from a height of 40 meter with the same speed along the same straight line of motion. At what points do the two balls collide? It is given that there is a tower or something, tree, tower or anything of height 40 meter. And we have thrown a ball vertically upwards from the base of this tower with a speed of 20 meter per second, and at the same time we have thrown a body in vertically downward direction from height of 40 meter with the same speed. So this is not the case of free fall. This is a case of free fall, but not in this manner, that in maximum cases what we do, we just drop the body, and when we drop the body it continuously falls towards the ground due to acceleration, due to gravity. But in this case we have not just dropped the body, we have thrown this body with a speed of 20 meter per second. So we have to find where the two balls will meet. Suppose this is the point where the two balls will meet and this distance is x. So from ground this distance has to be 40 minus x. Obviously both the bodies will meet after same time. So t is same. So if we apply two separate equations for both the bodies, and if we take these bodies individually, we take this body and separately we take this body, so both the bodies are moving in same direction throughout the question, right? So we can without using the sign convention, we can do it in the regular way like you used to do in class 9. Then if the body is going upward, then the g is negative, and if the body is coming downwards, then g is positive. So suppose this body is a and this body is b. So for body a, u is 20 meter per second, g is 9.8 meter per second square, t is t. At what points do the two balls collide? So we have to find x. Time bhi nahi given. So t is t and the distance is x. So let's apply the second equation. X equal to u t plus half g t square. And for the body b, let's apply the second equation. So for this body b, the distance is 40 minus x, u is 20, but the acceleration due to gravity is negative. Now we have to use these two equations, solve these two equations to find the value of x. Okay, now if we add these two equations, x plus 40 minus x, then x will get cancelled out and 40 is left, and then again 20t plus 20t, that is 40t, and plus half into 9.8 t square minus half into 9.8 t square, ये दोनों भी कट जाएंगे. So the t is, the value of t is 1 second. The value of t is 1 second, and if we put this value in any of these equations, we can find x. So what is x? Let's put this value in this equation. 20 into 1 is 20 plus half into 9.8. Half into 9.8 is 4.9. So the answer is 24.9 meter. So these two balls are going to meet at a distance of 24.9 meter from point A, or 40 minus 24.9, that is 15.1 meter from the ground, right? Okay. A stone falls from a cliff and it travels 24.5 meter in the last second before it reaches the ground at the foot of the cliff. Find the height of the cliff. A stone is dropped from this cliff and this stone is dropped from the cliff and this stone travels 24.5 meter in the last second of its falls. 24.5 meter in the last second of its fall. And right, have you got the question? That suppose the height of this cliff is 500 meter. So in the last second of the fall, we do not know what is that last second. It can be 10th second, it can be 11th second, it can be 15th second, but in that second it has traveled a distance of 24.5 meter and we have to find the height of the cliff. Okay, we will apply this equation, dn equal to u plus a by 2, but a is g in this case, into 2n minus 1. So we do not know the value of n because we do not know what is this last second, but the distance traveled in this second is 24.5. U is obviously u is 0 because it is dropped from the cliff, and g 9.8 divided by 2 into 2n minus 1. So we can find the value of n. 9.8 by 2 is 4.9, so we will divide this by 4.9. 4 into 5 into 5 is 25. So this is 5. Yes, this is 5. 2n minus 1. So 2n is 6. So n is 3. So the last second is the third second. So the total time taken by stone to fall is third second. So the height of the cliff is ut, u is 0, half g t square, right? Because the total time taken by the stone was 3 seconds. So let's put 3 in this equation and we will get the answer, h equal to 4.9 into 9. Height of the cliff is 44.1 meter. Height of the cliff is 44.1 meter. So the next topic is graphs of motion, but we are going to discuss this topic in very much detail. So this is the only topic which is left in this chapter. So we are going to discuss this topic in a separate video that is going to be uploaded after this video, right? So that you can grasp the concepts of graphs very deeply, because I am going to explain the graphs in much detailed manner. So we are stopping here. We have completed all the topics of motion in a straight line except graphs. So I'll meet you in that lecture. All the best.